Okay. So this design button, right? This design button is something called template method. Yeah. So this is also coming under behavioral. So we saw visitor last time. Yeah. So we did this. I put the comment on top. So you know that where do we use this? So this is very simply like, I mean, just to recap, I mean, we will have a class itself and we will have adaptations, so we'll tell, what other things he can visit. So he can visit the page or container and so on. Yeah, simple as that. So in any case, anytime you want to create a component to visit other classes than changing them, their internals, then we can have a visitor. So simple as that, right? So yeah, so this time, this one is called template method. Yeah. Yeah. Method. Yeah. So what does it do? So this template method, right? It's mostly, according to the book, it's mostly used in writing algorithms, they're saying, right? So when we write an algorithm, we need to write set of operations, right? So yeah, so when we say, we need to write a set of operations, the algorithm base class would have all the definitions saying, anyone who's going to inherit my base algorithm, you need to do all of these so that you can, have me defined, have me implemented, so so nothing surprising here because I mean we've been doing inheritance all the times, right? So we'll have a base class and then we'll inherit things from it, right? So yeah, just tell me, I mean, when you wanted to inherit behavior from a class, but at the same time, from a parent, say, and at the same time you want to override its functionality or behavior, what would you use? Would you use an abstract class or an interface?
If you wanted to say that again, if you wanted
Yeah,
to,
say that, I mean, you want to inherit from a parent, and at the same time, you want to override everything what the parent asks you to do. And also, if you want, sorry, if you want to implement all the parent force you to do, and also want to override any of the parent's behavior, default
okay,
behavior, what is the
yeah,
class? You would
abstract,
you
yeah, an abstract class.
exactly, yes, right? So we will use an abstract class. Interfaces, we will use if you want to just define certain functions or methods and
Mm.
you want to force
If
everyone
we
to
don't
implement
care
that.
about implementation.
Correct, correct. But abstract class, we can provide default implementations too. That's the difference between an abstract and an interface, right? Yeah.
Yeah.
Yes. So this is all about, I mean, if you have an abstract class, how would you let others inherit from it? Which we try to avoid as much as we can. But if it's just one class and we're going to have many other classes override it, it's okay. But anyway, we will see in a Java way now what we will do. So if we say that, the kind of an algorithm or some sort of any sort of every code we write is an algorithm, right? So if we want to say that, I mean, we want to write some sort of a calendar kind of an app, yeah. So what would be the calendar kind of an app would do? It will kind of see, what my day-to-day schedules are, right? So the calendar events, that's what I'm talking about. So calendar events, yeah. If you want to create calendar
Mm.
events as per day, what my schedule is like. So, that schedule will be something like, um, you know, I will be, where would we start? We will start something like, yeah, arrive at work, coffee, and then, um, yeah, meetings, um, lunch, and then meetings, some meetings again, and coding, yeah, and then yeah, go home. Yeah. So this will be a schedule for us at work, right? When we go to work every day. Yeah. So if you want to create this kind of thing, we will need some sort of abstract class, right? I'll tell you where the template method will come in, but then in order to define this, we can start with an abstract class. Say that day routine or something, right? Yeah.
Mm.
Right. Okay. So this day routine is going to define certain things. So if I want to create a day routine for Monday, I will simply say class Monday routine, which will extend my day routine, right? With me, right?
Mm-hmm.
Yeah. So but all of our routines should do this, right? No matter what. So we can see, what are the common ones everyone should do, everyone should implement. That will be something like, these meetings and this. The other things can change, right? So somebody might, have a coffee after they arrive to work, or they won't also not have coffee and things like that, right? Um, but the other ones, the meetings and this and that, they will be doing always, isn't it? Yeah. So we can force the Monday routine to have the common ones, the ones everyone should do. Yeah. These
Yeah.
are the main ones. So before lunch, we would always have the meetings and code. Yeah. So let's imagine that's what that's what we will do every day. Yeah. Mondays, Tuesday, Friday, up to Friday. We will always have this before and after lunch. Yeah. So we can push this into an abstract method, isn't it? So we can say abstract function um, do before work and do after work. Yeah. So those things we will always have in every day. Yeah. So immediately our Monday routine is saying implement these. You need to tell, you will have to do this. So we can say stuff I do work. Yeah. So this would be stuff I do. Sorry, after lunch. Lunch. This is I'm telling us before lunch and after lunch. Yeah. Yeah. You with me, Jason? Jason,
Yeah. Yeah.
are you following?
Yeah.
Yeah. So day routine. This is telling everyone who has this thing will implement this because of they are abstract. They will always do something before lunch. That's what I meant to say. They will always do something before lunch and after lunch, but in between that, they can have some of the things. I mean, they can do always. Like after, yeah, right, the work. They drink coffee. They're the common ones. The other ones they will have to implement in their way. That whatever they would do. In every day. Yeah. So
Oh, did you change it?
yeah. Sorry, this is lunch, no? Because imagine if this is our routine, we will write the word coffee, and then this will change. This would be anything. Yeah, we don't know what every day will be like. In this period, say this is 10
Okay.
to 12, and then lunch will be always definitely having on every day, right? And this could
Mm-hmm.
also have some different things. We'll have meetings or coding or whatnot. This or actually, we can have many. We can things might differ in this period, right? After lunch, also we can have something, and then we can go home. So these lunch, coffee, arrive to work, go home, and all that, they will be always the same in every single day. Yeah. So if I implement Tuesday, these are the ones we need to tell what we would be doing on that day. So Monday, we can say um, we don't really care that what we do, but so we can just say, these are the things we would be doing. So they can change per day. No?
Yeah.
Right. but then also say default implementations, like, I mean, what we do on the other things, so if you want, we can have a private function and so on. So other private function, coffee or something. Coffee. Right. See, so these are here, but because of we extend the parent, these will be running, right? So let's say the parent also has function run schedule, which will eventually run these. Yeah. So first it'll say arrive to work, and then it will run have coffee, and then it will say let's have one more for lunch as well. So have coffee, and then we can do this, do before lunch. No, we can ask to run this because this is the order of everyone would be doing every day. Yeah. Then we can have lunch, then do stuff after lunch, and then go home. Bye. Yeah. Okay, cool. So if we now run this, right? See, Monday routine is going to tell the parent that this is how he does the do before lunch and do after lunch because they are abstract. He needs to implement it. The rest of them are going to be common. Yeah. As the run schedule is calling all of them to run. Yeah.
Yeah.
So, okay. So if we have a main method now, let's see how this runs. So we will have to create a Monday routine. Yeah, and now we can say Monday routine dot run schedule. You see, because this is a public function. By default, every function in the class is public. Yeah. Yeah, you see, this is public now.
Yeah.
You will close it with a private one. So
Every function in the sorry, say that again.
Every function in a class will be by default public. If you hide it, you will see, I didn't have any access modifiers. If you don't have any access modifiers, that's by default public, isn't it?
Okay.
Yeah. If you want to hide it, we'll put private. Yeah. So yeah, that's why I could be able to call this. So this is actually calling the parent because a Monday routine is actually a day routine, and the day routine has this public function, which is run schedule, right? So we can call run schedule on it, isn't it? So if you run this, we would expect to see do before lunch and after lunch will be printed from the Monday routines methods, isn't it? Yeah.
Yeah.
Yeah. Why?
Because they're public.
Yeah. No, but then we also have these defined here, but they are what are they? They are abstract functions, aren't they?
Yeah, they're abstract.
And we are what are we doing here? We are
yeah, we call it we're overriding all the
correct. Yeah. Yeah. We override them and implementing them here, right? Because of these functions are getting implemented there. So it will get the moment it comes here, do before lunch, even though it's calling the abstract function in the base, it will see who overrides them. So Monday overrides it. So it will run this rather than because it's an abstract function. So he will see who is implementing this, and it's implemented here, so it will run this. No. Yeah, whenever this gets called, isn't it? This and this, right? Yeah, it's easy, no? Nothing complicating here, no?
Yeah.
Yeah, so you can see private functions are getting printed here. So arriving to work, coffee, stuff I do before lunch here. So that's our overriding of this. And then having lunch, stuff I do after lunch, go home. That's it. So that's our schedule on a Monday, right? So, right. So this is nothing complicating or nothing surprising, right? But let's see, how do we do this using Kotlin? This is the Java way of doing it, right? Of course, in Kotlin, we have functions. So how do we do this using Kotlin? That's the highlight here, actually, right?
Sorry, did you say something about Java?
Yeah, this is the Java way. I mean, you have an abstract class, and you have an inheritance of things and things like that.
Oh, okay.
Yes. Now let's see.
Yeah.
The book is showing us if this is in Java, this is how we would have written it by using an abstract class. Yeah. In order for us to come to a template method. In this case, the template method is this guy. This run schedule, because he is the one making sure everything is running. Yeah. This is the template method. Yeah. So what is a template method? The template method will be staying in an abstract class, in a parent class, and organize things, telling these are the recipes needed to have a routine, right? Like you know, the person who has the control, everything gets executed, right? So this is what we are interested in. How do we run the schedule? So we need to call this so that everything will be now executing, all the rest of the operations. And the things are decided by us telling it, I mean, how are we going to do these in order for the operation to run here, all these operations. So that's the template method. And we will decide for the template method to run whether we're going to have some operations private in the class or, outside of the class and things like that. Outside means, these are going to come from whoever is inheriting them, right? Yeah. So this is the template method, which puts everything together, kind of. Okay.
Yeah.
Yeah. Okay. Right. So how do we do this? How do we achieve this? So this is the design pattern. This is the design pattern, when we say template method, this is the template method, right? So how do we do this in Kotlin? Right. So we can actually write functions now. So let's start writing a function then. So we don't want classes and this and that. We can simply start with a function. Let's say that function is the run schedule, the template method itself. Yeah, run, but yes. So so when we say this, now we're going to just only talk everything in functions. Yeah, we're not going to be creating classes and stuff like that. So if you just have functions, we know that we can pass things as parameters, the lambdas. We can pass a function as a parameter into a function, right? We studied them, so we can pass lambdas into this.
Yeah.
Yes, right. So in order for the run schedule to happen, like we have just seen, people have to pass these no matter what. The rest of them can be implemented locally. The people have to tell whoever is calling that function should say, how are they going to run the do before lunch and how are they going to define the do after lunch? Yeah, those are the two things which are coming from outside. So let's put them as lambdas then. So do before lunch is the
You're
lambda.
saying this is the Kotlin way, yeah?
Yes, this is the Kotlin way, which is a super nice way. um, this is an empty lambda, right? Same, we're going to have do after lunch. Yeah, look how simple this is going to be, rather than creating classes and inheritance and all that crap. Right. Right. So now when somebody runs this, we need to run these too. Yeah. No question. So we can run this. This is a lambda. This is not defined there. Somebody will be sending the, functions into it, create the function and send them, create the lambdas and send them. When we get them, we will invoke them here, right? This is how we're going to run them, right? So do before and do after will be getting 1. Right, so no problem. But now if we are going to use the Kotlin way, this is the kind of a Java way, using classes. Yeah. We can call the function, no? So we can just call run schedule, right? But it takes 2 functions, which is do before lunch. Let's say that function is just about non-print list. Yeah. And there's another one, do after lunch, which is also going to print stuff. Yeah. Okay. Right. So we're passing these functions. Yeah. Which are these lambdas. Yeah. And if you run them, now these will get invoked here. So we can just run this function, no? In order to achieve the same. So this is our template method or template function, right? So we are defining our template function just without the class and everything, because of functions, we can use in Kotlin, no? With passing another function, which is a lambda. Yeah. Jason? Jason?
Yeah.
Are you with me or?
Yeah, yeah.
Tell me, any questions?
No, not in a minute. No, everything's all right for now.
Yeah, so you're happy, but okay, so we're passing these lambdas from outside, right? So whenever we call this function, we need to provide these lambdas, right? Yeah.
Yeah.
Yeah. So what about, okay, but what is missing at the moment then? In order for us to have a run schedule, we have these functions as well, but we have just got these done. But what about the rest of them? These and that and that.
You have
This
to
is what,
create lambdas for them as well.
exactly. That's a nice answer though. But what we can do is, but they are private. What we have here is to the abstract class, these are private functions. So they will just always run for every single day schedule, right? Because these would be always the common ones, yeah? But how do we do that in a function? So this is the function we have, right? We could also, as you said, we can create another functions and pass them as in, what they are, but we want to keep it local to this function. And this is the new thing. So we can create local functions inside the function too, So arrive to work will be a local function. Yeah. So that will print. And we can execute this too. That will be the first one now. You see? See, that's a local function. We cannot call this from outside. This will be only accessed by the function itself, the main function.
Okay, yeah.
Yeah, this is how you create local functions. Or another way, this is one way. The other way would also do the same thing, but it's another way of doing it. So we can create a val. See, inside a function, we can create vals, yeah? We can define vals,
Okay.
isn't it? So we can say, yeah, coffee. In this case, will be just like this, creating a val, but it's lambda value, yeah. Yeah. So now we can say write the work and we can execute that too. Coffee. But these are local to this function. That means kept private. Same like in a class, these functions are kept private. But in a function as well, we can create local functions by which are private to that. So coffee, arrive to work. What is missing? Go home is missing, right? So we can also do similar like this, or like this as well. Either. covered everything. Our lunch is missing now. Let's create lunch like this. So lunch will go here. Done. Right. So let's see now. If we now we are calling this function in the main method, so it should run all of these and it should print everything, right? So let's see it's also doing the same as what we want. So let's comment this out. So we won't run this. We're just going to call this function and run what we want. Like in Kotlin, you know. There you go. Arrive to work, coffee before lunch, lunch, do after lunch, go home. Done. So we have just created a template method. This is our template function actually, in Kotlin rather than in Java and all that. Sorry, using classes and everything. That's it. Template method in Kotlin.
Yeah. So everything's done with methods.
Functions.
Functions.
Yes. You see, this is all we want. This is the bit of code. And now we can delete all the other ones. You know, we don't need a class, which we have defined here. See all that code.
There's no inheritance going on.
Yeah, all that inheritance, we can just delete them. You know, you see, all that code, we can just comment it out. We don't need them.
Is it doing it under the hood?
No. Because if it's doing what it should be doing in functions, no? We call a function and pass in the, you know, other functions as parameters, in this case lambdas, to say what the do before lunch and do after lunch should be doing, and keeping the local functions to do the private behaviors, right? Isn't it? Yeah. So, but then if we don't use functions, you know, we have to create an abstract class and then we have to extend it to do stuff, you know? Yeah. But now by having a function, we can also do the same, but we can pass lambdas as parameters, and having local functions, we can achieve the same. You know, right. That's what I'm trying to show. So template method in this case, some sort of a function which takes control, which actually puts things together and takes control of what the thing should be doing. Imagine if this is the cookering recipe or something. You know, this is what's going to put everything together, saying what needs to go first and second and third. In this case, a schedule. You know, I mean, a day-to-day routine at work. You know. So this one schedule is what is putting everything together, saying in the order of, and I mean, what function should be running at what time and what at when and what, you know. But yeah, so that's the template method. But we are using local functions to achieve the to run the common ones, and the other ones which can come from outside with lambdas. You know, so the template method can receive operations from outside and can have operations inside to put some sort of an algorithm by itself, you know. So that's the template method. Yeah. So that's template method in a nutshell.
Okay.
Yeah. Let's read what is a template method. There you go. We don't want to, maybe this one. Yeah. Template method design pattern is to define an algorithm, there you go, as a skeleton of operations and leave the details to be implemented by the child classes. The overall structure and sequence of the algorithm are preserved by the parent class. You see? So something needs to preserve the order of the operations, but that thing, which is the template method, is the one which is preserving the order of the operations, can receive from the children or outside that some operations, and he can also define some operations within himself. That's a template method, like a parent, which is putting things together by receiving things from outside and having things inside too. That's what they're telling me. But this is the Java explanation of it. Like that's what they're saying in abstract class and this and that, child class, parent class,
Mm.
but we have done the same using Kotlin functions, so we don't need an abstract class and this and that,
Mm.
yeah, that's it, man. Right, so this we can commit it in, and we have just done the next design pattern, so we can update the readme too. So this is, any questions so far?
No, it seems pretty straightforward. It's just
Yeah,
if it's
easy,
built
isn't
on
it?
top of Java, I thought it was going to do.
Yeah.
I thought it would be visible where the inheritance was happening, but it's a totally different system.
Correct, exactly. Yes, exactly. So that will be the definition of a template method.
I suppose the lambdas make all the difference.
Yes, exactly. And it's shorter and neat as well, right? It's so concise, right?
Mm.
Oh, yeah.
That coffee you've got,
Yeah.
you've just put it straight in a lambda
Yeah, exactly.
on its own.
Yeah, but it's a val. You can create functions as values. I mean, we can create the function and define it to a value, right?
Yeah.
Assign it to a value. But that's a lambda. These are also lambdas, but these are defined in a argument. This defined as arguments, function parameters, right?
Right.
Yeah. Or this would be
Where
this
did
would
you call that coffee?
sorry?
Oh, the coffee's been called in the.
Yeah, here. Invoked here. So
Oh,
we just tell here, because these are passed as parameters, we just tell, what the type of that thing is. Like, you'll pass a string. So you
yeah.
say name or something, and then you need to say the type of it, no?
Mm-hmm.
Exactly like that. So you say what the function is, name of the function is, and then the type is this. It doesn't receive anything, it doesn't return anything. So that's an empty lambda. Yeah. Which
Yeah.
in this case, the coffee is the same, but it's a that val. It's just not
It's been implemented
yeah,
straight away, isn't it?
straight away. Yeah, yeah. Whereas you can implement this here too. I mean, you can provide the default parameter implementation there too, but we
Mm.
are expecting it to come from outside, so
Yeah.
we can do it like that. Yeah, we can do all sorts of things, with Kotlin functions. That's why it's powerful. See, look at the bit of coding. I mean, it's only just this much lines
Mm.
to achieve the same. So we can achieve the same with Kotlin function and as local functions. Yeah, so we can achieve the same with Kotlin functions and lambdas as well as local functions. Boom, done. So we need
Mm.
lambdas, Kotlin function as the template method, and local functions. Yeah, so these are the local functions. You can
The local functions are not. Oh, they're the public ones.
they're not the public ones, they are the private ones for the function itself. You can't access these from outside. You can only access it within the main function itself, as they are defined only within the function, within the function. You see? Yeah. But
Oh, we're the private ones.
these are the private ones. These are the private functions. But when we did it in the Java way, we were creating the private functions within the class here, inside the class, abstract class. We were creating the private functions.
Mm-hmm.
But now we can just create local functions within a function. This is not inside a class. That's why I don't need to make this private. You don't need to.
Gotcha.
Yeah, you see, there's no need. It's not allowed here, you know, because of them, the local functions are themselves private to the main function. So, but to create local functions, there are two ways. You can create it like this, or you can create it like that. So this is exactly like we normally create a function, but that's created inside the main function. So this is being the local function, you know. Yeah. And that's it. That's about it, really. So I'll uncomment this because, you know, we can see them as well, you know, when if you want to refer to this for now. So I think that can be there. Yeah, yeah, cool. We can have this too. Cool. So we know it's the Java way. Let's comment this, and we're done. Done. Cool, man. Just less than a minute, and we're done. Okay. I can stop the recording and we can continue with the rest of the other things, yeah?